Hello everyone, welcome back to my JEE Physics channel. Today we are going to solve JEE Advanced 2025 sample paper is given by IIT Kanpur. Okay, so you can see the question paper here. So I'm highlighting JEE Advanced 2025. It's a sample paper. Okay, so given by IIT Kanpur. Okay, at the end you can see this is the copyright by IIT Kanpur. Okay. So now in this video you are going to see all the solution for the first section 1 I am going to solve in this video. So similarly for section 2 I'll keep one more video, and for section 3 also I'll keep one more video. Okay, so total they have given 18 questions, I think so. Yes, it's 18 question paper. So 2 paragraphs given, and more than one option questions, even numericals given 14 to 9. Okay, numerical 6 questions they have given, and more than one option questions they have given. Okay, so 4 questions more than one option given. So more or less I feel this would be the pattern for the 2025 question paper. So you'll find single option, and this is also rarely you'll see single option, more than one option guarantee, and numerical question, integers, and maybe paragraphs. Okay, and last probability you can give for matchings. Okay, this may be the pattern for 2025 what I'm expecting. Okay, so let us solve question by question. Okay, in first question they have given that a spherical drop when deformed slightly oscillate about equilibrium in shape. The frequency of oscillation, this is the frequency, can be described by mass, radius, and variable some x is some variable, which can be universal gas constant or surface tension. Okay, so then K is dimensionless, they are asking alpha, beta, gamma. So it's a purely units and dimension question which can be attended by so many people, I feel. So just you need to verify the alpha, beta, gamma numbers. Okay, first what I'm taking is I'm taking the x is equal to gravitational constant g. So the dimensions of g will be m power minus 1, l power 3, t power minus 2. This is the dimension formula for gravitational constant, capital G. Now frequency, they have given the equation something like this. So F is equal to K into m power alpha, r power beta, and I am taking the x as g power gamma. Okay, so then F dimension is m power 0, l power 0, t power minus 1. Okay, so it's a frequency 1 by time period, 1 by time. So m stands for mass only, so I'll write down m power alpha, and r is nothing but length, so length power beta. G is nothing but m power minus 1, l cube, t power minus 2 power gamma. Okay, so if that is the case, I'll get m power 0, l power 0, t power minus 1 dimension on the left side is equal to m power alpha minus gamma, l power beta plus 3 gamma, and t power minus 2 gamma as it is. Okay, if I'm equating, I'll get minus 2 gamma is equal to minus 1, gamma is equal to 1 by 2, then alpha minus gamma is equal to 0, then gamma is equal to alpha, or alpha is equal to gamma, then alpha also will be 1 by 2, then beta plus 3 gamma is equal to 0 again. So gamma is equal to, or beta is equal to minus, beta is equal to minus 3 gamma, so beta is equal to minus 3 by 2. Okay, so one answer is matching, that is with the B option matches with this. Alpha value is 1 by 2, gamma value 1 by 2, beta value minus 3 by 2. When I'm taking the x value as universal gravitational constant. Now let us check for surface tension also. Okay, so we got one option according to the gravitational constant. So let us verify for surface tension. Okay, so if I take x as surface tension, so we know that surface tension units are, surface tension will be force per unit length. Okay, this is force per unit length, then ml t power minus 2 force by L. Okay, the dimension goes to m l power 0, t power minus 2 will be the dimension for the surface tension. Then we have F is equal to K into m power alpha, r power beta, x is nothing but surface tension, I am taking as s power gamma. Okay, so let us write down the all dimension formulas. M power 0, L power 0, T power minus 1 is equal to m power alpha, R is nothing but L power beta, S is nothing but M L power 0 T power minus 2 power gamma. Then M power 0 L power 0 T power minus 1 is equal to then M power alpha plus gamma, then L power beta, then T power minus 2 gamma. If I am equating it, I will get alpha plus gamma is equal to 0, even beta is equal to 0, then minus 2 gamma is equal to minus 1, then gamma is equal to 1 by 2. Then gamma is equal to 1 by 2 means alpha is equal to minus gamma, then alpha is equal to minus 1 by 2. So finally it is minus 1 by 2, beta value 0, gamma value 1 by 2. So minus 1 by 2, 0, 1 by 2. Minus 1 by 2, 0, 1 by 2. We are getting even A option also. Okay, so both options are correct we are getting, but they have given single option. It's okay, it's a sample paper, so we can expect here and there. Okay, so this is about first question. Let us go to the second question. So this is the second question as given. An unpolarized monochromatic beam of light is incident on planar surface of two medium of refractive index as given n1 n2. Angle of incidence is I. It is found that reflected beam is completely polarized. See, by reading this statement, reflected beam is completely polarized, then automatically we need to get Brewster's angle. Brewster angle, plane polarization or polarization concept, polarization by reflection concept. Brewster angle. In the Brewster angle, what happens when a light is incidented, reflected ray will become completely polarized. This is like completely polarized under one condition. What is that condition? Is the refracted light is perpendicular to reflected light. Refracted is partially polarized will get, refracted and reflected light both will be perpendicular to each other. Once you can verify this. Okay, if you remember it's okay, otherwise we verify the ones reflection, polarization by reflection, which is nothing but we call it as Brewster angle. Okay, so then angle of refraction is something like, let us say that R dash, then I can write down R dash plus 90 plus R should be equal to 180. This entire angle I am taking as 180. So this is a known phenomena. It's a direct R dash plus R is equal to 90. Okay, then R dash we can write down 90 minus R. Once I know the R dash value, we can apply the Snell's law. So by Snell's law, what I can write down is, by Snell's law, then mu 1 into sin I should be equal to mu 2 into sin R dash. Okay, so mu 1 into sin I is equal to mu 2 into sin of R dash can be written as 90 minus R. Okay, so mu 1 sin I is equal to mu 2 cos R we can write down. Okay, even cos R is nothing but cos I also we can write down, mu 2 or n1 n2 you can write down anyway. So this I can write down I, because I is equal to R. Angle of incidence is equal to angle of reflection. Then tan I stands for n2, okay, by n1, or you can say mu 2 by mu 1, anyway it can be. So then I value is tan inverse n2 by n1. So I value is tan inverse n2 by n1, we can say that. What about other options? See, n1 greater than n2 or n2 greater than n1, we cannot say anything, because this reflection, polarization happens by reflection, can be done from rarer to denser, denser to rarer also. Both the possibilities are there. That's why we cannot say which one is greater, which one is less. Only we can comment about the angle of incidence. So obviously this is not the angle of incidence. This should be the answer. Let us see the third question. So third question is related to thermodynamics as given. Mostly it's something like an efficiency of cycle they are talking about. By looking at the diagram, we can say that 1 to 2 is isobaric process. 2 to 3 they have given isothermal. Okay, isothermal as given. Even 4 to 1 also isothermal as given. And 3 to 4 is again isobaric. Okay, so this temperature for 4 to 1 is T naught, 2 to 3 is 1 plus beta T naught, and here pressure value is given P naught by alpha. So which of the following statement false they are asking. So let us see what options will get correct. Okay, then obviously as it is single option, one option will be wrong and remaining 3 will be correct. So they have given different alpha and beta values. Unfortunately we got A and B. See, whenever you get this type of questions, even in the final exam, so remember, if they have given different alphas, different betas, so don't try, my suggestion is don't go with numbers. Instead of going with numbers, just try to solve in general alpha and beta terms, and finally you keep the alpha, what is alpha value, what is the beta value. So that will be useful, I think so. So hope you understood what I told. Okay. So what I'm doing is I'm also going to solve in general this question first of all. So what we require the efficiency of cycle according to the first option. So let us go with an efficiency of the cycle. For efficiency of the cycle, we must know the total work done in the cycle, at the same time heat absorbed by the gas in the cycle. Okay, it's not heat rejected. Remember, for efficiency it should be heat absorbed. So for that, what I'm doing is I'm going with the 1 to 2 process. First process 1 to 2, which is isobaric. So as it is isobaric, what is the work done I'll get? I'll get work done is simply nR dt. So nR into dt, T2 minus T1. T2 is nothing but 1 plus beta T naught. Final temperature minus initial temperature. So I'll get nR beta T naught. See, I'm calculating in terms of beta and alpha. This is I told. Okay, so we calculate in terms of alpha and beta, and final we write down the alpha and beta values to verify any option. Okay, this is the work done. We are getting positive work done. And what is the dq value? As it is isobaric, I can write down directly ncp dt. So n into cp value I can write down 5r by 2 because they have given the gas as ideal monoatomic. Okay, so that's why cp value I wrote 5r by 2 into again temperature difference, something like this, T2 minus T1. So 1 plus beta T naught minus T naught. So this simplification you can do it. Then it is 5 nR beta T naught by 2. This is also positive heat. See, always whenever you are calculating the efficiency, which one is positive, which one is negative, that you need to verify. Next we'll go with the 2 to 3. 2 to 3 is an isothermal process. So we can say that du is 0. As du is 0, dq and dw both are same. Okay, which can be written as nR into temperature. Temperature is 1 plus beta into T naught. ln of actually V final by V initial. Here V final by V initial is V3 by V2. Okay, or else you can write down the P initial by P final also if you know the pressures. So as we know the pressure P naught and P naught by alpha, so what I'm going is I'm going in terms of pressures, because as we don't know about the volumes. So nR into 1 plus beta T naught multiplied with ln of P initial by P final. P initial is P naught by P final is P naught by alpha. So we'll get nR 1 plus beta T naught ln alpha. So this also we got positive work done as well as positive dq. Now 3 to 4 is isobaric. So again directly we can write down. Okay, so dw work done is equal to nR into T final minus T initial, which is nothing but T4 T naught, T initial 1 plus beta T naught. So obviously as 1 to 2 is 1 to T2, you are getting positive work done. 3 to 4 volume is decreasing, work done should be negative. Okay, so what you will get? You will get here n minus nR beta T naught. So it's a negative work done. And what about the dq? dq is equal to again ncp dt n into cp value 5r by 2 into dt value again T naught minus 1 plus beta T naught. Okay, so here also will get negative q value minus 5 by 2 nR beta T naught. This is negative. That means heat is rejected in this process. So while calculating for efficiency, we should not count this. Next 4 to 1 again isothermal. As it is isothermal, again we can write down dq is equal to dw is equal to nR temperature, which is T naught. 4 to 1 temperature is T naught. ln of V final by V initial, V final by V initial, V1 by V4, or you can write down nR T naught. Okay, P initial by P final. P initial means P4, which is P naught by alpha, by P final is P naught. Then this is nR T naught. Obviously minus you will get ln alpha. ln 1 by alpha you will get, you can write down minus. So here dq is negative. Here also heat energy is rejected. So now we can write down the efficiency is equal to total work done. Work done in 1 to 2 nR beta T naught, and work done in 3 to 4 minus nR beta T naught. These two will cancel out. You see the work done. This is the work done, positive work done. This is the negative work done. Both will cancel out. And here we are getting the positive work done. here you are getting the negative work done. Okay, minus nr t naught ln alpha, nr 1 plus beta t naught ln alpha. If I am going for resultant of these two, or if I am adding those two, resultant means adding. Okay, so I'll get nr t naught ln alpha cancel out, you will get nr beta t naught ln alpha. This is something like in mathematics by dq which is positive. So here dq is positive, here also dq is positive. I can write down 5 by 2 nr beta t naught plus nr into 1 plus beta t naught ln alpha. So if I cancel the nr beta t naught in everywhere, then I'll get ln alpha by 5 by 2 into 1 plus beta by beta into ln alpha. Okay, so finally this is the efficiency I got. What the efficiency is? Ln alpha by 5 by 2 plus beta 1 plus by beta into ln alpha. Okay, so they have given the ln alpha value is nearly in the question they have given ln alpha value 0.7. Okay, alpha value is 2, beta value 1 by 4. So that is the thing we need to verify. See, we didn't verify the options, now we are going to verify. ln2 is nothing but alpha value 2 is given. So ln alpha is nothing but alpha 2. If 2 is alpha is 2, then it is 0.7. Okay, beta value is 1 by 4. Beta value is 1 by 4. So then what is the neta value I'll get? I'll get 0.7 by, this is 5 by 2, 2.5 plus 1 plus beta by beta. 5 by 4 by 1 by 4, it is 5 into 0.7. So you'll get 0.7 by, so I'm checking for first option. Okay, 3.5 you'll get, it is 0.7 by nearly 6, 0.1 something you'll get. So very close to 0.12 I can take. Okay, so efficiency value is nearly 0.12. So I can say that first option is correct, but this is not the answer for the question. They are asking for false statement. Don't forget that. See which statement is false. This is correct one. Now we'll check the next part, Q2 to 3 and 1 to 2. Okay, so Q value 2 to 3 divided with Q value 1 to 2. This ratio we require. Q value 2 to 3. 2 to 3 is nothing but here Q value is nr something 1 plus beta t naught ln alpha, nr into 1 plus beta t naught ln alpha. This is the Q value. As it is modulus, no need to go for sign. And 1 to 2 is dq value. dq value, yes, yeah, Q value they are asking, which is nr 5 by 2 nr beta t naught. 5 by 2 nr beta t naught. So nr beta t naught will cancel out. No, nr t naught will cancel out. Then you will get 2 by 5 into 1 plus beta by beta into ln alpha. Then 2 by 5 into 1 plus 1 by 4 by 1 by 4 is nothing but 5. ln2 is 0.7. This is 7 by 5. You will get 1.8. No, sorry. 1.4. 1.4 you will get. This ratio is 1.4. Yes, that is also correct option we got. This option also correct, but not the answer for this. And work done in thermodynamic cycle, total work done they are asking. What is the total work done? So total work done is, see, this is positive work done, negative work done. Okay, positive work done, negative work done. The total work done value we got here, see once, nr beta t naught ln alpha. Okay, so what the total work done goes to? Total work done goes to nr beta t naught ln alpha. This is the total work done. But what is given in the option? In the option is given beta p naught v naught. Let us see. So beta into nr t naught ln alpha. So beta into nr t naught. nr t naught can be written as, see, t naught is the temperature at first point, state 1. First state you can check. If you check this state, what the pressure is? P naught is the pressure, T naught is the temperature, volume is V naught. So I can write down P naught V naught is equal to nr T naught. So in the place of nr T naught, I can write down that P naught V naught into ln alpha. Okay, so total work done is we got beta P naught V naught, ln alpha term also there, but here ln alpha term is not there, so that's why this option is wrong. Now let us check when beta is far less than ln alpha, efficiency of this cycle is Carnot cycle working between same maximum and minimum temperatures. See, when this is the maximum temperature and this is the minimum temperature, that is the meaning. Okay, this is maximum and minimum. Then what is the efficiency of Carnot engine? 1 minus T lower by T higher you can write down, or else you can write down T sink by T source. So 1 minus, it is T naught by 1 plus beta T naught. Okay, then what is the efficiency for Carnot cycle? For Carnot cycle, efficiency goes to 1 minus 1 by 1 plus beta, then it will be beta by 1 plus beta. This is the efficiency of the Carnot cycle. Let us see whether we will get it for this condition or not. Okay, so I am checking each and every option. Then what is the efficiency we got in the cycle? We got the efficiency here. This is the efficiency I got. This is the efficiency. So I am using the same thing. So ln alpha by 5 by 2 plus 1 plus beta by beta into ln alpha. Now just divide the ln alpha, then it is 1 by 5 by 2 ln alpha plus 1 plus beta by beta. What they told is, they told that ln alpha is far greater than beta. That means ln alpha is having the huge value. So that means 1 by ln alpha tend to 0. Then neta efficiency will tend to this value tend to 0, 1 plus beta by beta. Okay, so then efficiency value is beta by 1 plus beta. Okay, so beta by 1 plus beta efficiency is equal to efficiency of the Carnot cycle. That means the fourth option also correct. So for a given question, what is the answer is? Answer will be C, wrong option. So let us move to the fourth question. Yeah. So in this question they are given one dimensional box of size L. Already this type of question has given previously in the JEE only, advanced only. Okay. So box size is L. Now 4 electrons are there. Mass of each electron is E naught, ME. E naught is the ground state energy. Alpha value, some value is given, Planck constant and all, non-interacting, obeying the Pauli exclusion principle and described by standing de Broglie waves confined within the box. What does it mean? It means, see, first of all I am explaining what is happening in the box. Let us say that this is the one dimensional box of length L. Then electrons are moving in this. As electrons are moving, there will be de Broglie wavelength. As electron is moving with some velocity v, then what is the de Broglie wavelength or matter wave? Wavelength is equal to h by p or h by mv. Okay, this we know already. So these waves will form a standing wave, something like this. Okay, so how many loops are there? This we don't know. Let us take n loops are formed. N loops are formed in the standing wave. Then what is the immediate relation we can write down? L is equal to n times of lambda by 2. That means what is the wavelength we can write down? Wavelength value is equal to 2L by n. This is the wavelength. Okay. So if this is the wavelength, then what is the momentum of electron? Momentum of electron we can write down h by lambda is nothing but nh by 2L. This is the momentum of electron. Then we can write down the kinetic energy of electron. What is the kinetic energy of electron? Half into me into v square. Also you can write down p square by 2me. So we know the p value. So 1 by 2me into p square. You will get n square h square by 4l square. Okay. So you will get n square h square by 8mel square. This is the kinetic energy of the electron, one electron. So then energy of the electron will be, okay, n square into, I can write down h square by 8me square l square. If you see this expression, you will understand. H square by 8me square l square will be alpha. So I can write down this is n square alpha is the energy of nth state. That means n loops are formed, that will be in the energy of the nth state. If one loop is formed, that will be the ground state energy. Then what is the energy of ground state energy? Ground state energy goes to, okay, ground state means n value 1. Ground state energy is simply alpha. So from this we can say that the first option is wrong, because the ground state energy they have given E naught, then E naught value goes to be alpha. Similarly, what is the first excited state energy? First excited state energy goes to n value obviously what? 2. Then you will get 2 square alpha, which is nothing but 4 alpha. Second excited state energy. second excited state energy goes to how much? 3 square alpha, which is nothing but 9 alpha. So this 9 alpha can be written as E naught, which is nothing but alpha plus 8 alpha. This can be written as E naught plus 3 alpha. So first excited state E naught plus 3 alpha. So obviously we can say that from this C option is wrong, and total energy of the second excited state I can write down E naught plus 8 alpha. I can say that D option is correct. But what about the energy of the highest occupied state? So what is the energy of the highest occupied state? See here, for this particular option you will get the Pauli's exclusion principle. Okay, according to Pauli's exclusion principle, we cannot keep electron with same spin in the same state. So I don't know how you studied in chemistry in different ways. So the electron should have the equal and opposite spins in the same state. Okay, so according to the Pauli's principle, I can write down that 2 electrons in the first state, 2 electrons in the second state. Okay, so if 2 electrons are in the second state, then what is the total energy? Total energy of highest occupied state. So they are asking the total, it's not total energy, they are asking the energy of the highest state. If energy of the highest state, then simply what you will get? Energy of the highest state goes to n is equal to, n is equal to is nothing but 4 alpha. 4 alpha is the energy of the highest state. Even if I are taking the total energy of highest occupied state, total energy means 2 electrons, 2 into 4 alpha, you will get 8 alpha, not 16 alpha. Okay, so anyway, even if you are taking the total energy or energy of the highest occupied state, the B option goes to wrong. So what is the correct answer for this? Is D option is the correct. Okay, so this is about section 1. Next video will be on section 2. All questions of section 2 I solve and post in the second video, and similarly third video all paragraphs I'll solve. Okay, so please stay tuned for the next video, second video on the section 2, and third video on the section 3. Okay, so if you like my efforts and explanation, please don't forget to like, share and subscribe the channel. Okay, if you like, if more likes I'll get, more comments I'll get, then automatically YouTube algorithm will take my video to pop up to the different people. Okay, so like that channel will grow. So your support definitely will help the channel to grow, no doubt in that. So hope you enjoyed all the questions. So please prepare in the similar lines for whoever writing the 2025 examination. So you try to prepare in this way. Okay, so that you will get a optimum marks, more marks in the examination. Okay, so we'll see in the next video. Thank you so much.